Good afternoon, everyone. In the last class, we discussed about two important algorithms, that is task scheduling algorithm. One is the round robin, another is our list scheduling, right? So the input to these algorithms are nothing but a set of applications. You can see those list for them. I am repeating. These are the applications you have to give input, and each application has the application ID, and each application has a arrival time. Like you can see here, the application 1 has arrival time 0, application 2 has arrival time 3, application 3 the arrival time is 9. Next is these applications can be submitted to the cloud in two different forms. One is advanced reservation, another is the best effort. So here we assume that the first application is a best effort application, okay, where you have flexible time, okay. Second application is the advanced reservation application, but here for the simplicity we assume that there is no start time and there is no end time. But if a B leads or a B task is assigned to a computational resources, then AR can preempt it, because AR is having higher priority than the best effort task, right? Similarly, we assume that the third application is the best effort application, right? So note that very important part, AR has a specific start time and end time. For this illustration, we assume that there is no specific start time and end time. However, we assume that once AR lease is ready, if a B lease has preoccupied that slot, then this AR lease is going to preempt the best effort lease. That means you have to give the first priority to the advanced reservation, second priority to your best effort leases or tasks, right? So this is the concept. By using this concept, we'll see how we are performing. And we also assume that one best effort task cannot preempt another best effort task, or one advanced reservation task cannot preempt another advanced reservation task. Another constraint is that if a B request is preempted from a particular cloud, then it needs to schedule in the same cloud only. Suppose it is preempted from cloud 1, then it will be rescheduled in cloud 1 only. You cannot switch to other cloud, even it is free, right? So based upon that, what we did here, we have taken three different clouds, okay, three different cloud service provider, you can say, and whenever you are assigning A to the cloud 1, then it is taking 2 units of time. But whenever you are assigning to cloud 2, it is taking 3 units of time. Whenever you are assigning A to the cloud 3, it is taking 5 units of time. Similarly, other tasks are taking different time in different cloud service provider. Sometimes they may be same. Like here you can see G is taking the same amount of time in cloud 1 and cloud 2 respectively, right? So once you are getting this matrix, okay, or you can assume that this matrix is given to you, you can apply the very two popular algorithm. One is called as round robin algorithm, another is called as a list scheduling algorithm, where round robin says that the tasks need to be dispatched to the resources in a particular order. Like A is assigned to 1, B is assigned to second cloud, C is assigned to third cloud, D is assigned to first cloud, E is assigned to second cloud. Similarly, F is assigned to the first cloud, G is assigned to the second cloud, H is assigned to the third cloud, and I is assigned to the first cloud. So you can see the sequence here: 1, 2, 3, 1, 2 for the first application, 1, 2, 3, 1 for second application. Similarly, for third application, it is 1, 2, 3. So in this order, you have to dispatch the user request, or the task, or the job, or the lease. But whenever you go for the least scheduling algorithm, what you are doing, you have to find the minimum of all the minimum among all the clouds, all the available clouds. So if you see here, the minimum time is achieved in cloud 1. So I am assigning it to cloud 1. Suppose for E, the minimum one is achieved in cloud 3. So we are going to assign to cloud 3. Okay. There is a mistake in this representation, that here you can see I case, it is taking minimum time in the first cloud. So it should be 1 year, not 2, it is 1 year. Right? So once you find this order, you can perform the schedule. So in today's class, I will tell you how to schedule. Once you determine this order, or once you have decided that in which cloud you are going to deploy that particular task, then what is the procedure is going on with respect to this precedence constraint, with respect to the priority of the application like AR and B, and with respect to the execution time of the application, that we are going to see in today's class, right? So for this, I have prepared a Word file. Okay, so you can see here the Word file. I hope it is visible. So you have decided in round robin. Let me zoom this thing so that you can clearly see. Okay. Okay. Now this is given to you, and I have prepared a Gantt chart here. This is a Gantt chart for the round robin, empty Gantt chart. I have taken the time from 0 to, let's say, 29, some 28, some 29, like that, and I want to assign these things, these tasks or these applications to the 3 different clouds, right? So as you have already decided, if you see this table, you have decided from the cloud A. I can take a new row so that I can write. Okay. So for cloud A, for cloud 1, you will assign A. If you see round robin, you have decided here. You will also assign D. You will assign F. You will assign I and J. So these are the 5 tasks that we are going to assign to cloud 1. Similarly, for cloud 2, you are going to assign B, E, then G, next is your K. So these are the 4 tasks that we are going to assign to cloud 2. Okay, I am getting this in from this row. Wherever 1 is mentioned, I am keeping in cloud 1. Wherever I am keeping, wherever 2 is there, I am keeping in cloud 2. Wherever 3 is there, like C is represented by cloud 3, C is going to assign to cloud 3. H is there and L is there, that I am presenting in cloud 3. Okay. Now let us start scheduling these tasks to the cloud. So you know that at the time t is equal to 0, this application is arrived to, as submitted to the cloud service provider, was arrived at the cloud service provider end. So the very first application, or very first task in this application is A, and you have decided A need to execute in the first cloud. You can see here A I have written in the first cloud. So what I will do, I have to schedule A, and A will take how much time? As you have decided that A is going to be assigned in the first cloud, it is going to take 2 units of time. So I am writing here A and A. It is taking 2 units of time. One is 0 to 1, another is 1 to 2. Right? Next, now A is completed. So let me change the color of A because it is already assigned. Next, you can see the second application is arriving at 3 units of time. So I'm making it bold, right? Similarly, at 9 units of time, cloud application 3 is arrived. So till now you do not have any information of the application 2 and application 3. Okay, only application 1 is live, okay, available at time t is equal to 1 to 2. Okay, or at time t is equal to 0, only one application is there and only one task is ready, that is A. That's why I am assigning A here. So once A is completed, what you can do? you know in directed acyclic graph, when root task is completed, its children task is now active. Okay, so BC is now active. As BC is active now, I have to decide to whom I have to assign. So you check, you have already decided B you need to assign to cloud 2, C you assign to cloud 3. So let me assign B here, because once A is completed, then only you can start B. That's why I'm not starting B from here. A is completed here, so in the next time slot only I can schedule B. But how much time it will take in cloud 2? You know, 8 units of time. So I'm writing B 8 times, right? So 8 units of time you have decided. Okay. Later it can be changed, because you do not know when your task will be available, right? So now I can say B is completed, right? And I am taking the scheduling decision at a time t is equal to 2. Similarly, C is assigned to third cloud. So third cloud also it is going to take how much time? 8 units of time, right? So I have assigned C also. C is now also completed, right? Now at the time t is equal to 3, what happened? At time t is equal to 3, an advanced reservation application is arrived to the system. As advanced reservation task is arrived to the system, it has highest priority than the best effort. So it can preempt the best effort application. So F you can see here, F is written under cloud 1. So F require how much time in cloud 1? 4 units of time. So what I will do, I will assign F in the first cloud for 4 units of time. So there is no problem. Up to this there is no problem. But once F is completed, F is completing at what unit of time? 7 unit of time. Once F is completed, G is now active. Okay, let me represent it by red color. It is completed. Then I can start G, right? So G is assigned to which cloud? G is assigned to cloud 2. How much time it is taking in cloud 2? It is going to take 8 units of time. Okay, so what I will do, I will print this B. Okay, I will print this B. I will print this B, right? So you can say now these B's are printed. Okay, or you can strike out. Okay, better to strike out so that it is more clear, otherwise you are confused. Okay, let me strike out. B is now printed for 3 units of time. 5 units of time it is completed, but 3 units of time you have to give priority to G, because G is an advanced reservation task, right? So but G will continue up to 8 units of time. Now G is completed. Okay, we have assigned at 7 units of time and we are expecting completion by 15. Once G is completed, then you can assign H and I based on the precedence. But we will go time wise, right? Okay, G decision you have taken. Now what happened? As B is not completed, if B is not completed, then D cannot execute. If B is not completed, E also cannot execute. What you have to do? You have to wait. You have to wait. Okay. But in between, what happened? Another application arrived at the time t is equal to 9 seconds. Another application is arrived. What is the first task in that application? First task in the application is J. Right? So see, J is assigned to which cloud? J is assigned to cloud 1. J is assigned to cloud 1. It will take 8 units of time. What I can do? I can start J here and it will take 8 units of time. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, and sorry, this G is completed, but B is not completed. So I am making it black color. Okay, G is completed, B is printed, that's why it is not printed. Okay, now next scheduling decisions we will take once G is completed, or once B is completed, or in this case once J is completed. Out of these three, which one is earliest? Earliest is G. So once G is completed, you have two tasks active. One is H in the last cloud, which takes how much time? H is taking how much time? 6 units of time. So I am assigning H here 1, 2, 3, 4, 5, 6. 6 unit of time, right? And you can see here H is completed. Another is I is also active. I is also active. Okay, and I need to execute in the first cloud. As I need to execute in the first cloud, J is a best effort task. So J also need to print it. J need to print. We have to print J and we have to resume I here. Okay, for how many unit of time? 4 unit of time. Okay. See here, J is now discontinued because J is an best effort task, I is an advanced reservation task. Now the advanced reservation task is completed. Once advanced reservation task is completed, what I told you? I told you if any best effort task is discontinued, like here best effort task is discontinued, that is resume. Okay, like once it is completed, we can resume it. Right now, the J is completed. Right, and here J is completed, but because of I, it is printed. Right now, J is completed. I is also completed. No, then in this case, B is also completed. Okay. Now, once B and C is completed, at this point particular time, B and C is completed. So, what are the other tasks left? D is left. And in this application, once J is completed, KL will be active. J is completing by 21. But you can see here, B, C, both are completing. Okay, if you see their maximum completion is at this particular time. So once it is completed, D you can schedule, right? D means what you can do? D is here and E is here. Okay, so if you assign E in the second cloud, it is taking how much time? 9 units of time. 1, 2, 3, 4, 5, 6, 7, 8, 9. So E is completed. E is completed now. Okay. Coming to D. Now I want to schedule D. D I can schedule here, right? But at that time, an advanced reservation is going on, right? And once advanced reservation is completed, I can assign J, right? I can assign J because J is started earlier, but due to advanced reservation, it is printed. So once J is completed, what I can do? I can resume D. For how many unit of time? D will take 7 unit of time. So 1, 2, 3, 4, 5, 6, 7. Right now 7 is completed. D is completed. What are the other tasks left? The task left is K. At what time they can take? We can take decision. So J is completing by 21. So from 22 we can schedule K and L. So KL is assigned to which cloud? K is assigned to cloud 2, L is assigned to cloud 3. So if you see, K is taking 3 unit of time in cloud 2. So I can write here K, and I can take that into K, which will complete by 30 unit of time. At the 30 unit of time, K will complete. K is taking 3 unit of time. Now, L I can assign. Okay, K is completed. L I can assign. If you see L, after completion of J, J is completed here. So L I can start from here. L for how many unit of time? 4 unit of time. Okay, so this is the complete scheduling using the round robin algorithm. Right? Where the strikeout things are nothing but the best effort task, which is printed temporarily, okay, printed in order to accommodate your advanced reservation task. Okay, so if you calculate the make spend, in this case, if you calculate the make spend, the highest one means the overall completion time. If you calculate in this case, that is nothing but overall completion time required to complete the 3 application is 30. That is the maximum time. right? So this is the scheduling algorithm you have to apply. So you can cross check once you are done. You have to cross check. Like you can see, A is executed twice. A is 2, so it is 2. It's okay. Then F D is assigned for 1. D is assigned. Okay, D is here. Let me check. D is assigned for 7 unit of time or not. 1, 2, 3, 4, 5, 6, 7. Yes, D is also correct. F is assigned, so it should be 4. 1, 2, 3, 4. Yes. Then I is assigned for 4 unit of time. Yes, I is for 4 time. J is for 8 unit of time. Okay, 8 unit of time. So come to the second cloud. B is assigned for 8 unit of time. 1, 2, 3, 4, 5. And here 3, 8. And after that, E is executed for 9 unit of time. So let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's okay. Then for the second cloud, G is assigned for 8 unit of time. So it's 1, 2, 3, 4, 5, 6, 7, 8. Okay. Next is K is executed in the second cloud for 3 unit of time. Yes, it is 3 unit of time. Now come to the C. Task number C needs 8 unit of time in clouds. 3, 1, 2, 3, 4, 5, 6, 7, 8. And if you see, H is taking 6 unit of time. So it is 1, 2, 3, 4, 5, 6. And L is assigned to the third one. It is taking 4 unit of time, right? 1, 2, 3. Okay. In this way, you can schedule your round robin scheduling. Okay, and generate the Gantt chart. So if you have any questions, you can ask. After this, I will go for cloud list scheduling. Have you understood how it is working? Can anybody respond? Or if you have any doubt, you can post or you can unmute and ask. A similar kind of problems it will come with examples.
How do we know which one to prioritize over the other?
No, here with respect to application, it is already mentioned that application 1 is your best effort task. Application 2 is advanced integration task. Okay, and application 3 is your best effort task. It is already mentioned. So once any task of the advanced reservation is arriving, if that slot is allocated to any B task, that you have to print. One example is here, right? B is already occupied, but what happened? G is belongs to, okay.
Yes, sir.
Yes, G is belongs to your advanced resolution task. So what happened? G printed your B. And once a best effort task is printed from a particular cloud, it needs to assign to the same cloud only. Okay, you cannot switch. See here some slots are there, right? Somebody may say that why not assign to this slot? But that's why I told you prior to receiving this thing, there is a constraint that even if there is some space in other cloud, you cannot switch because you already decided that this cloud is going to solve the task number B. Okay.
Okay,
so
sir.
this is yes.
So also the tasks will already be assigned and given to us, as in which task is going to be executed in which cloud.
No, that you have to apply in round robin, right? You know that first task is assigned to first and 2 and 3 and 1 2. Only this thing will be given to you. These applications with their arrival time is given to you, and this table is given to you. Okay, you have to determine this thing. Okay, and this one. These two parts is you have to solve, right?
Yes, sir.
And here, while referring this PPT, note that there is a mistake here, so it should be 1, not 2. Okay, I will correct it. But still remember, while you are studying, you should not confuse. The minimum one is for the list scheduling is cloud 1, not cloud 2. Okay.
Okay, sir.
So next, let us move to the next algorithm. So that is called as a list scheduling. I have taken a blank Gantt chart. I will just show you. So before going to that Gantt chart, let me tell you that what are the tasks you are going to assign A. because this thing is completely online. So this row I have it is not required. But as you are given with all the data, you can write for easy calculation. Right? For task A, you can go for cloud 1. Task H, you can go for cloud 1. Task I, you can go for cloud 1. Task L, you can go for cloud 1. Similarly, for cloud 2 case, you can go C and F, and let's say next one is J, and this K. Okay. For cloud 3, you can go B. Okay, next is D, next is E, next is Z. Okay, so 4 plus 4 plus will be easy. And what is the sequence? What is why the order is changed? Because in the first case, you are assigning first task to first cloud, second task to second cloud, third task to third cloud, fourth task to first cloud. Because you have 3 clouds, right? That is round robin fashion. Whatever we are studying in the operating system, the same thing we are applying here, right? Only the difference is that in operating system we have a single processor, single CPU, but here we are using multiple CPU or multiple processor, or you can say that it is applicable to cloud computing, right? So here you can see in the least scheduling, you are mapping your task with all the clouds, but you are picking a cloud which takes less time. Okay, so at time t is equal to 0, you have only one application, right? And I told you that application 2 is arrived at this point, and application 3 is arrived at this particular point of time, right? And one application is arrived at 0 in the time. That's why I make it bold. So that's why we are reading is an identity. Okay. Now, at time t is equal to 0, you can see only one application is available. That is your application number 1. That to be only one task is available. That is A. And A is taking minimum in which cloud? As per the least scheduling, it is taking minimum in the first cloud. So what I can do? I can assign A. For how many unit of time? 2 unit of time in the first cloud. That's why I assign 2 unit of time to A. So once A is completed, what you can do? You can assign B, C simultaneously. We have seen this concept in data structure, that is directed acyclic graph. So once A is completed, then I can execute B and C parallel. But B and C, I need to execute in which cloud? You can see B is here in cloud 3, C is here in cloud 2. So C is taking how much? B is taking how much time in cloud 3? B is taking 4 units of time in cloud. So it is B, 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 and B, right? 4 units of time. Similarly, C is taking how much time in cloud to 2, 3 units of time? 1, 2, and this 3. Right? Now ABC is completed. We have taken this decision at time t is equal to 2. But at time t is equal to 3, what happened? A advanced reservation application is arrived in the system. And you know that advanced reservation task is having more priority in comparison to our base application. That's why. So first task is F. You can see in application 2. Root task is F. F need to be assigned to which cloud? F need to be assigned to cloud 2. We already decided because F is taking minimum time in cloud 2. Right? What I will do? So I have to print the C and C to F here because F is going to take your in the second cloud it is taking 2 units of time. So I am printing C, okay, and I am assigning the resources to F. Right? So C is printed. That means C is not completed till now. Okay, but F is completed. So once F is done, you can start G. For G, which one is the most appropriate machine? Cloud 3. Why Cloud 3? Because Cloud 3 takes less time for G. So G can start here, right? G you can start at this point of time, right? By putting 1 unit of B and it continues for 3 units. So B is not allocated. I can say B is not executed now, right? So once G is completed, you can start executing H and I. Okay, H in which cloud? H in cloud 1. So let me start H here. H is taking how many minutes? 2 minutes of time in cloud 1. I can assign in which cloud? In the same cloud. You can see I can assign to the same cloud. If it is assigned to the same cloud, it will be executed one after another, right? So 1, 2, 3, and 4. 4 units of time, right? H is 2 units of time followed by I. Sometimes people can say that I followed by H, but we are going for chronological order, or we can say alphabetical order. So H is followed by I, right? Now, whether B and this task will resume only, we can start the task number D and task number E only if B and C is completed. But B is printed here and C is printed here. What I can do? Once F is completed, I can resume 2 units of time for C. Once G is completed, I can resume 1 unit of B. Now B and C will be complete by this particular stage. But prior to that, the prior completion of PU, we have highlighted this one. What is the meaning of this one? This meaning says that application 3 is arriving at 9 minutes of time. If application 3 is arriving at 9 minutes of time, which one is the root task? J is the root task, right? J is the root task. This root task J is assigned to which cloud? It is assigned to cloud 2. Okay, and prior to that C is completed. So C is completed. Now B is also completed, right? Okay. So J is taking how much time? J is taking 4 units of time, and it should be assigned to cloud number 2. So what I can do? I can start J here, J here, J here, and J here. Right? Now J is completed, right? The next one. Once J is completed, what you can do? You can take this one of care, but at this particular time, B and C is completed. C is completed here. B is completed here. So now you can resume D and E. So D in which cloud? D is assigned to the same cloud, that is cloud number 3. D requires how much time? 5 minutes of time. D requires 5 minutes of time. So I am assigning D, and D, right? 5 minutes of time followed by E. For how many units of time? 2 minutes of time, right? So now D is completed, E is completed, but the decision we have taken at this particular time, right? At the time E is equal to 10. Now, once J is completed, you can start KL. Once J is completed, you can start KL, right? And K in which cloud? K in the cloud 2. If K in the cloud 2, okay, cloud 2 means how much time it will take? It will take 3 minutes of time. 1, 2, 3. 3 minutes of time you also. Okay, now K is also completed. Now come to L. L is taking how much time? L is taking 3 units of time. Okay, sorry, L is assigned to first cloud, it is taking 2 units of time. So you can assign L here. Once I is completed, you can assign L. Okay, so this is the schedule you are going to get if you are applying least schedule. You see one of the important concept here. What is the make explain? Let us cross verify. What is the make explain you are getting here? Next one is the overall completion time. Overall completion time of one of the task is 7 days. So let us check whether we have correctly calculated or not. And I told you this one is not true, this one is not. Right? Okay, task A is taking 2 minutes of time. Okay. Task A is taking 2 minutes of time. Task H is taking 2 minutes of time. H is taking 2 minutes of time. Task I is assigned 4 minutes of time. 1, 2, 3, 4, yes. L is assigned to the first cloud, which is taking 2 minutes of time. C is taking how much time? 5 minutes of time. Sorry, 3 minutes of time. Yes, C is taking 3 unit of time, that is correct. Then F is taking 2 unit of time, yes, F is taking 2 unit of time. Then you can say, okay, J is taking 4 unit of time, yes, J is taking 4 unit of time. A is taking 3 unit of time, yes, A is taking 2 unit of time. B is taking 3 unit of time. Sorry, B is taking 4 unit of time, 3 unit of time here, 1 is limited here, that's why we have assumed here. That's okay. Then you can say B is assigned for 5 unit of time. Yes, B is assigned for 5 unit of time. E is assigned for 2 unit of time. Yes, E is assigned for 2 unit of time. Then G is assigned for 4 unit of time. Yes, G is assigned for 4 unit. So this line check is correct. In this way, you can schedule using the list schedule. Is it clear this scheduling part? Or if you have any doubt, you can ask. So the overall comparison, if you see with round robin, in round robin, how much time you have spent? You have spent 30 unit of time. But in this shifting, how much time you have spent? Only 7 unit of time. That's why if scheduling algorithm, if the scheduling algorithm is efficient one, then definitely you will get a less investment, and with the limited resources also sometimes you can get a better result. That's why scheduling plays an important role in the task scheduling. Right? Now let us continue our discussion. There is the slide. Okay. So now you know how to schedule. So sometimes the questions may come with 5 terms, sometimes the question may come with 2 terms, sometimes the question may come with multiple number of applications. Like that, the question will go. Or sometimes a new algorithm is given to you. You have to read the algorithm and you have to understand the algorithm. Based upon that, you are going to schedule a set of application to a set of class. Now, if you go for workflow scheduling, this is also called as workflow scheduling because here you have seen that you have 3 workflows. You can see you have 3 applications. So these applications are sometimes called as your workflows, right? So to evaluate a workflow scheduling algorithm, we should measure its performance on some sample workflow. If you have designed a scheduling algorithm which is meant for your workflow, okay, you have designed a scheduling algorithm which is applicable for a set of workflow, then how to judge the performance of such scheduling algorithm? In order to judge the scheduling algorithm performance, you have to rely on some sample workflow, right? So, in order to generate some sample workflow also, there is 2 things. One is, there is 2 ways you can do it. One way is you can use a random connected acyclic generator. Okay, there is some tool is there where you can generate the connected acyclic graph randomly, or you can write an algorithm to generate the connected acyclic graph randomly. While generating such random predicted acyclic graph, okay, you have to take various characteristics. That's what I'm saying. Using a random predicted acyclic graph generator to create a variety of workflow with different characteristics. You cannot generate without these characteristics, right? That's why you have to focus on how many tasks you want to put in the workflow, in which order, or in what is the precedence constraint or constraint among the task, depth of the workflow, width of the workflow, and many other things you have to keep in your mind while generating the random predicted acyclic graph generator. Right? The next one is using a library. If you don't want to write a program to generate this acyclic graph, what you can do, you can go for the second option, where it says that the second case it is saying that using a library of realistic workflow which are used in the scientific or rigorous community. There is some workflows, realistic workflows or real life workflows you can say that is available. You have to take these workflows and accordingly you can apply a suitable algorithm. Right? Some predefined realistic workflows are there. These workflows are belongs to some real life projects. For example, here you can see the structure of 5 realistic workflows for diverse scientific applications are these 5 things. One is montage. First workflow name is montage, which is belongs to the astronomy related project. Second one is cybersec. It is belongs to the earthquake science project. Third one is epigenomics, which is a biology oriented project. Okay, workflow. And LIGO, which is a gravitational physics workflow, and SIPST, which is a biology oriented workflow. Right, these are the standard workflows. You can take the standard workflows, accordingly you can generate your various values or various properties of the task and the communication type, or you can say computation type, you can provide. So let us see how these workflows look like. You can see here montage case you see. So montage case what happened? There are 4 root tasks. Okay, that's why in the previous slide I told you while you are generating a directed assembly block, you have to take the depth. Okay, you need to consider the depth. You need to consider the width. Right? You need to consider how many tasks are there in the workflow. For example, here you can see 4, 6, 2, 4, 4. Okay, these many tasks are there. That is 10, 20 tasks are there. Right? That we have to give it an input. 20 tasks. Its depth that you have to specify. Width you have to specify. Based upon that, you can generate random directed assembly. But here this one is not random. This one is realistic workflow which exists physically. Okay, this workflow structure is present in some scientific or engineering project. So once you have defined this workflow, if you are taking a realistic workflow, what you can do? You can generate the computation time or you can generate communication time. Based on the structure, what you can do? You can generate these values. Right? So that the if you generate this one, then after that you can apply computation algorithm or you can say resequencing algorithm in order to solve the problem. Right? So you can see epigenomics. Epigenomics project also you can see here there are 16 set of tasks are there, right? And total is again 20 tasks are there, but the structure of the montage and the structure of the epigenomics is different. For example, we assume that these are the similar type of tasks. What I can do, I can take a 4 processor, right? In the first processor, I can assign this A because we cannot A. Once A is completed, what I can do is B, C, D, E. I can assign to 4 different processor. If they are similar tasks, we will complete at almost the same time. Then I will start A, G, H, I, okay, or J, K, L, M, like that. Okay. Once I B is completed with G, H, I, okay, with G, H, I, then J, K, L, like that. Right? So you can see you are taking the structural advantages. You know that these are the 4 task sequential tasks. So you can assign to the particular processor in order to take the advantage. Okay. So for the epigenomics project also we can generate such workflow. So this is another workflow that is called SIPST. The structure is more complex in comparison to epigenomics. Based on that also, what you can do, you can generate workflows. Right? Workflows means you want to generate the communication time and computation time. But in the round robin and resequencing algorithm, we assume that there is no computation time. Because whenever you are moving from task A to let's say task B or task C, you are assuming you are not giving any computation time. Sorry, communication time. We assume that this computation time and this time is negligible or equal to 0. But in real life, it is not 0, right? So that also you need to consider in order to say that all the constraints you have incorporated in order to develop a particular scheduling algorithm. Okay, so this montage epigenomics SIPST belongs to your astronomy, earthquake science, and biology. Okay, some already predefined structure is there based upon the project work, so they have defined this one. Similarly, you can see LIGO and SIP, LIGO and CyberSec. Okay, this is SIPST, that is a biology project, and LIGO and epigenomics you can see here. Sorry, LIGO and CyberSec you can define it. Okay? So you can see more or less their structure is different. So you can apply or you can develop a particular solution which is best fit for LIGO or best fit for CyberSec or best fit for any two workflows out of 5 workflows, something like that. That you can do. Right? So this is the way you can take the library of linguistic workflows. So you can see some library of linguistic workflows are already there. So if you are giving input, just like I mentioned, the number of tasks, number of depth, number of width, you are going to give the values. Okay, of the communication time and computation time. So based upon that, you can schedule. Okay, the tasks to the class. Okay. So also while we are discussing the service oriented architecture, also I told you workflows are generally used. These are the workflows you can use in the service oriented architecture as well, or with respect to chemistry, or with respect to physics, or with respect to the material science. Also, some of the workflows are there. So that workflows you can take for simulating or finding the performance of your algorithm. Okay, this is another workflow you can see. So, although I will discuss this thing in the next class, let me introduce this program so that I will stop. So, here you can see total we have 6 tasks, that is starting from T1, T2, T3, and T4, T5, and T6. There are 6 tasks are there, and you have 2 time. Okay, you can write here T1, T2, okay, T3, T4, T5, and T6. Okay, and T1 takes 5 minutes of time, T2 takes 7 minutes of time, T3 takes 3 minutes of time, T4 takes 4 minutes of time, T5 takes 2 minutes of time, T6 takes 8 minutes of time. Okay, irrespective of the number of processes. Here number of cloud is not mentioned. You can take a single cloud, you can take a multiple cloud, okay, and you can take cloud 2, you can take cloud 2. So multiple cloud you can cancel. Right? So these things are not mentioned, and we assume that even if multiple clouds are there, they are taking the same amount of time. Okay, means they are having homogeneous structure, not heterogeneous structure. Right? So these values are given to you. In addition to that, what happens? You have another matrix that is called as your communication time matrix. This is your computation time matrix. This matrix, okay, first matrix is called as your computation time. Computation time. Okay. Second one is called communication time matrix. Let me show how the communication matrix looks like. So communication time matrix. So in the communication time matrix, it is nothing but our agency matrix, in which we have T1, T2, T3, T4, T5, T6. Okay. So similarly, we have T1 here, T2 here, T3 here, T4 here, T5 here, T6 here. Right? And you know that this is a square matrix. So you can say the diagonal element is 0, right? This one diagonal is 0. Because there is no communication among the class itself. So here you can see T1 is connected to T2, right? So T1 to T2, the communication time is 4, which I have written in the form of a rectangle. T1, if you are communicating with T3, you have to pay the cost of 3. Okay. T1 to T4, you have to pay the cost of 7. And T5 and T6 is not directly reachable from here. Right? Similarly, for T2, you can achieve that T2, T3 connection 12 and okay, T2 to T5 it is 8 and the rest are 0. Right? Similarly, T3 case, you can see T3 is only communicating with T6 and its time is 4. T3 to T6 is okay, 4. Rest are 0. Right? Then T4 case, it can be assigned to T5 and T6. T5 it is taking 9 minutes of time. Okay, then it is taking 9 minutes of time. T1 to T4. Sorry, T4 to T5 it is taking 9 minutes of time. T4 to T6 it is taking 10 minutes of time. The rest are 0. Right? Similarly, for T5 it is communicating with T6. So T5 to T6 is 5, the rest are 0. Similarly, T6 is not communicating with T1. Okay, so it is 0. And you have to maintain their precedence. This T1 to T2 it is 4. Right? It does not mean that the T2 to T1 is also 4. And it should not be considered, right, in this case. So it is a one way because this is a directed edges are there, so you have to take care before assigning a particular schedule number, right? So if you see in the previous case, the computation time is given, but the computation time varies with respect to the time service provider. But this program, you can see computation time is same for all the time service provider. Second one is that this communication time we have neglected in the previous program. When we are discussing round robin and list scheduling, but here we are not ignoring it. And that is the advantages we are going to get in this particular program. We are relaxing in terms of computation time with respect to the cloud service provider, and at the same time we are considering the communication time in order to assign this task to the users.